Hi everybody, welcome back. And today we are going to continue with the normal distribution. But today we're going to look at using these probabilities on a calculator. So if you have a graphing calculator handy, if you want to go ahead and grab that and hit pause for a moment, might be a good time to do so. If you do not have a graphing calculator, just like I did last time, I'm going to post an online calculator in order to calculate some of these normal distribution calculations, and I will have that in the modules as well. So you can either use your 84, and I'm going to have instructions for the 84, but I'm also going to show you or put a link to an online distribution calculator as well, which is basically the same function. So let's go ahead and get started. So as we saw before, we talked about a normal distribution curve where we have the mean and the standard deviation, and we're looking for probabilities, the probability densities between certain values. Like here's an example. If I've got a normal distribution curve with a mean of 10 and that's the variance, 2.3 squared, right? But a standard deviation of 2.3, right? So mean of 10 and a standard deviation of 2.3. And let's say I want to calculate the probability of x being between 8 and 11. So we know that is the derivative, right? The integral between 8 and 11 of the function. And here's the curve here. So it's this area that we have shaded in here. Underneath the curve is the area of that curve between 8 and 11 of the normal distribution function curve. So what we're going to do is we're going to use our calculator for it this time, because before it was easy when it was one or two or whole number multiples of the standard deviation away from the mean. But what if we just have other values? So let's say we've got this. We want to look at the normal distribution with a mean of 10 and a standard deviation of 2.3, and we want to look for the probability that x is between 8 and 11. So let's do that first. So we're going to, very similar to what we did last time, we're going to go on your calculator, we're going to hit the second key and then the distribution key. And this time we're going to go down to number 2, which is normal CDF, the normal cumulative distribution function. And it's going to ask us for lower and upper. Now, you notice by default, it has -1 to the 99. So it's this really small number. If for some reason that's not in there, if you don't want to reset your calculator, turn it off and back on, you could put 0 in there and get a pretty accurate answer, assuming that we're looking at values of lower being 0. But for right now, you can leave that in if you were looking at just an upper number, which we'll talk at later. But for now, since we have a lower and upper. Our lower is going to be 8, and our upper is going to be 11, right? So 8 and 11. And then what's our mean? Our mean is 10, and our standard deviation is 2.3. So we're going to put those values in the calculator, 10 and 2.3, and then go down to paste and hit enter. And you should get an answer here of 0.4758. So I'm going to say that answer is going to be 0.476 as that probability for A. And that's for the probability that's going to be between 8 and 11, which makes sense. The mean is 10, so about 50% chance of it being between 8 and 11. That's a reasonable one. Let's look at number 2. Number 2 says when it's less than or equal to 12. What's the probability that's going to be less than or equal to 12? We can imagine that's going to be pretty high, right? So here's 12, and we're looking for all of this probability here, right? So it's going to be pretty high. Let's go ahead and, again, go back to our distribution and on the calculator. So hit second vars. And again, down to number 2, which is the normal cumulative distribution function. And now, since we're going less than 12, lower, go ahead and put 0 in there, which is fine. And then for upper, we're going to put 12. So lower 0, upper 12. Or if the other number was in there, scientific notation really close to 0, that's fine too. What's our mean going to be? Well, the mean is 10, and the standard deviation is 2.3 like we had before. And let's go ahead down to paste and hit enter. And you should get... so the probability that x is less than or equal to 12 is going to be approximately 0.8077, so 0.808, right? And which we said 80%, that makes sense. That's a large majority of the graph. And then finally, the last one, part C, says, what's the probability that that x is greater than 9? So what are we looking at here? Greater than 9 is going to be, if this was 9, whoops, let's go ahead and back up. And if this was 9 right here, right, so it's all of this probability. Again, looks like a large amount. It includes the mean, so it's probably more than half. But remember, we can't do greater than on the TI-84 calculator, right? So what do we have to do? We have to do our answer and then subtract it from 1. So kind of keep that in mind. So here for part C, we're going to go back to the same. Second vars, we're going to go to number 2. And our lower is going to, again, be 0, and our upper is 9. So 0 and 9, and then our mean is 10 and 2.3 standard deviation, right? And hit paste, and we get the answer of 0.3318, right? But that is for less than 9. I want greater than 9. And remember, it doesn't matter greater than or equal to with the normal curve. The or equal to, the inclusion doesn't matter because of the probability when it equals. So what we're going to do is now subtract that from 1, right? So we're going to do 1 minus answer, and I'm going to get the probability for that is approximately equal to 0.668. Oops. 0.668, and there we go. And those are our probabilities using the calculator. So check those out. There's the answers there as well too. And again, remember we said that less than or 9 or greater than 9 or greater than or equal to 9 for a continuous distribution is going to be exactly the same. So that's how we do it on the calculator. There's another example here. You can kind of look through. I included that, but I won't go through the individual steps. But it's the same idea. At least 75. So we have a mean of 179 and a standard deviation of 7. So this would be when at least 175. So probability of x greater than or equal to 175. And then here between 170 and 190, you can see the calculations that we do and the answers that they have there as well. Basically very similar to what we just did. I do want to do one more example though. So let's look at this. It says, and this is where you have to think about what the numbers, where they go in the problem here. It says, so the time taken by students to complete a puzzle is normally distributed with a mean of 28.3 minutes and a standard deviation of 3.6. So minutes is what we're looking at for our x-axis, right? So now I want to know, check the probability that a randomly selected student took at least 30 minutes. So what's the probability that a student's going to take at least 30 minutes? Well, that's the normal CDF. So let's look back at second vars, and we go to number 2, and at least 30 minutes, right? So is that going to be greater than or less than? Well, it's going to be greater than 30, right? But I've got to, so that means I'm going to have to subtract it from 1 once I get the answer. So my lower is going to be 0. Whoops. My lower is going to be 0. Let's try that again. My lower is 0 and my upper is 30, right? And then my mean is 28.3. And my standard deviation is 3.6. So 3.6, and then go to paste, and I get an answer of 6.68. Now remember, that is, I'm looking to say that it took at least 30 minutes. So I'm looking for the probability of x being greater than or equal to 30. But what they showed me here so far was the probability of x being less than 30. So I need to do 1 minus that probability. And so I'm going to do 1 minus that. So 1 minus that answer. And I get that probability is approximately equal to 0.318. And so be careful. Remember, if you ever need something greater than, then we need to do that 1 minus at the end because our calculator always gives us less than. Let's look at part B though. Part B says, out of 10 randomly selected students, what's the probability at most half of them took at least 30 minutes to complete the puzzle? Well, we're selecting 10 students and we want to know the probability of 10 of them taking at least 30 minutes. So we know the probability of a student taking 30 minutes is 0.318. But if I'm selecting 10 of them, at random, what's the probability that at most half of them took that? This is not one of the problems that we've been doing. This is like what we did last chapter. This actually is going to be a binomial cumulative distribution function, right? So let's go to that. So in this case, we're going to go down to second vars, and we're going to go down to B like we did last chapter. This is a binomial problem. The trials, how many trials? So there's going to be, I'm picking 10 students, right? 10 students. My probability, well, I already calculated my probability up there is 0.318. Probability is 0.318. My X value, how many of them do I want, am I looking for? Well, I'm looking for at least, I'm looking for at most half. So it means less than or equal to 5, right? So I'm looking for less than or equal to 5. So I'm going to put in 5 here. So let's put that in. 10 for my trials, probability of 0.318, and my X value is 5. And then I hit paste, and I go down, and I get the probability of, now, so this one's a little bit different. This is a probability of, I'll call it Y instead for this one. And the probability of Y being less than or equal to 5 is going to be 0.938, right? And that's going to be, so that's a binomial problem like we did last chapter. So keep that in mind. That one's a little bit different because I looked for, remember my X value in this original problem was the number of minutes. So I got the number of minutes, and then I have a different problem. I was looking at, well, at, how many, if I pick 10, at what's the probability that at most 5 of them will have, what was the problem? Will complete the puzzle in 30 minutes. The probability was 0.318 for 1, so I wanted to do for 5 out of 10, and that was that was like that's a random variable. That's like what we did last chapter. So kind of mix the two together and kind of see the difference between the two types of probability problems. So that's it for this section. I've got some problems down here for you. This is section 24B, numbers 2, 6, and 7. So check those out. Again, please make sure that you post them into the assignment section. If you have any questions, do not hesitate to send me an email, or feel free to post some questions on the discussion boards as well. That's it for now. Talk to you later, and we'll see you next time.